In this video, we're going to solve a subnetting problem. What is the first valid host on the subnetwork that the node 192.168.233.145/27 belongs to? A couple things to notice here. We are using CIDR notation, so that /27 represents our subnet mask, and we have an IP address that happens to live somewhere within a network. And we need to figure out what the first valid host on that network is. So that's going to be the first one after the network ID. So the first thing I want to do is I want to convert that subnet mask to binary. I like to use a visual method for subnetting. So I'm going to use this CIDR notation and draw out 27 ones. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, and the rest will be zeros. Something that I'll notice right away is that the first three octets are all ones, which means that my answer, is not going to change in the first three octets. My answer will be 192.168.233 something. I just need to figure out what that something is. And it's not going to be 145 probably, but it could be, I suppose. Now the next thing I want to do is I want to convert my IP address to binary and put it down here. Except since I already know that it doesn't relate to my first three octets, I only really need to convert this part to binary. So I'm going to go a little bit quicker here. I'm going to take that 128 out of the 145. If you're rusty on your decimal to binary conversions, I've got another video for that. You might want to check that out. So my answer is 17 remaining. So I have a 1 here, 64 doesn't fit, 32 doesn't fit, 16 fits, and then I know the 1 fits. 8, 4, and 2 don't fit. So 1, 0, 0, 1, 0, 0, 0, 1 is my 145 in binary. Next thing I like to do is I like to draw out my N1LB chart. My N1LB chart is a way to visually represent the beginning and the end of my subnet as well as the hosts in between. So I draw a line where my subnet tells me that the networks live here and my hosts live here. Now, something I will always know is that my network side doesn't change. It will be 100 all the way down. And my host side will change. My host side is what will define my network ID, my first, last, and broadcast addresses. And that's what my N1LB represents. Network ID, my first usable, my last usable, and my broadcast. So these carry down because my network side never changes. From the first host to the last host, from the network ID to the broadcast, the network side will never change. That's why it's the network side. It doesn't change depending on different hosts within that network. They're all part of the same network, so the network cannot change. And on the host side, I can tell you that the network ID is always all zeros. Even if we have multiple octets to go, all zeros all the way down to the end of the address. That network ID is always the smallest possible number you can write in the host portion. On the opposite side of that, the broadcast is always the largest number you can write. So it will always be all ones, and it'll always be the opposite of the network ID. Now, the answer we really need is the first valid host, the first usable host. So one way I can see this is if these are my bookends, the very beginning of my network and the very end of my network, this first usable host represents the smallest number I can make that isn't already this one. That smallest number I can possibly write is this, is 1. And the last usable host is actually the opposite of my first usable host, and it's all ones and then a 0. So if I needed the network ID, the last usable host, or the broadcast, I could simply convert those back from binary to decimal, but this is the one that I actually want to convert back. And just doing this kind of quick in my head, going from binary to decimal, I know this place is worth 128 and this one's worth 1. So 128 and 1 is 129. So my last octet is 129. The first valid host on the subnetwork that this node exists on is this, and it ends in .129.